Well, I make a habit of doing things that people say I can't do. Walk through fire, water ski blindfolded, take up piano at a late. Oh my god.
Piano at a late.
So welcome to the second part. I'm going to introduce here the PLC programming to make a short video, and of course the third video is going to be real long. I just make a video of the simulation because we can see it slowly how this whole thing works, because in the real interface with a microcontroller it's real quick and we cannot see the bits shifting. That's why. Let's go and take a look. So as the previous video is almost the same here. So you have to get the impulses to shift and pick the impulses and put it in the word and shift the word, and to use a counter for that. And I had to introduce this change here with ends and nuts, because I want to ensure that this set bit is only going to be made in this part of the programming. It's a code, yeah. It's leather, but it is leather. It's a code. Anyway, so it's the same. So in this part, the microcontroller is going to send the PLC data, and we're going to store this in the word 110. And of course, up here, all those algorithms with set and reset is not going to be happening anymore. I'm going to change that kind of algorithm, programming a PLC algorithm. I'm going to change that to another way of programming, a sort of professional way. It's not really professional, but it's really close. So that's why I use this ends and nuts. Yeah. And here I have to use a bit to make the change happening. Yeah. So let's go to the next section. So I made a bit to make a loop, and with the word that comes from the microcontroller, I mean the data that the microcontroller, I will compare 1, 2, or 3. If I send from the microcontroller 1, this bit is going to be set. This value is going to be put on the word 120. Yeah. So I can further here down rotate the word and put the PLC to bit by bit pulse out into the microcontroller. Yeah. So let's see how this works. Perhaps I'm going to make some simulation here. So because in real time it's really quick and we cannot see everything. Simulation is sort of ideal for this video, although I don't want to extend this video so much in time, but so that doesn't become boring. But anyway, let's make this. So 1, 2, or 3. One of these three bits is going to be set. So this words, this value is going to be passed to the destination 120. Or this value AAA or 01010101, or in the case 3, 4 times 0, 8 times 1, and 4 times 0 again. So you can use this in a machine, you can use this to extract data from the for maintenance or for quality check. Yeah, I mean, there is several ways to do this, and you can extract data um, periodically. You can store this data from the PLC into an SD card or an USB stick. Yeah, I mean, yeah, that's why it's good to have a easy to program microcontroller like STM32 that can that as the already the ways to and the drivers to implement SD um, drive or a USB stick. Yeah. So let's go further. So we have the options. We're going to store up this word on the 20. You're going to rotate, and you're going to push the output. So we can the microcontroller will read the outputted pulse from the PLC. So the microcontroller is here, the master. The microcontroller is going to give the impulses. It's going to give the order and the impulse and to tell the PLC when to jump and when to do this. Okay, let's go and see the code. So here we're going to set the microcontroller output into the input of the PLC now to say so this bit or input will say that the microcontroller expects at this point that the PLC will send the 16 bits, yeah, or 16 pulsars. Yeah. So, and this bit is made, and this is the bit for the loop. So, and the loop is made with a timer to, yeah, the timer, in case of nothing happened, the timer will reset everything again. Yeah. So this is the loop. The first bit is only the first impulse is only to read the first bit of a word. So the first impulse is to read this bit from word under 20. Yeah, and this is going to be set in another bit so we can send it then out. Yeah, so we can send it out. But I'm going to make the simulation. I'm going to simulate this in a while. So the first bit, the second bit is going to the when the impulse is off, when the microcontroller, the output of the microcontroller is off, the board is going to rotate right. Yeah. So yeah. Okay. And this counter is only to debug. It was only for debugging. It's really not needed here because it is the microcontroller who is the master and he gives the orders when the PLC to jump, jump and then to give the impulses. Yeah. So, and of course, a professional way you have to implement all these ends and knots and yeah. So you can set the output on and off as you should need. So you're going to see here in the simulation the all 120 word. It's all this 16 bits or at least 15 bits. Yeah, plus 1, 16. Yeah. So let's see. Let's do the simulation. Let's simulate this. Let's say we are the microcontroller and we want to choose the option 2, and the option 2 is set. The option 2 is here the 3 A's hexadecimal, so it's 01010101. So we can see the bits one by one down below. So you're going to set the bit on. So the 2 is set. compared. So it's going to put this value in the 120 volt. Further down, oh wait a second. Okay, yeah. This timer I have to deactivate because this is going to be slow. So this bit is not, this timer is not important for now because you're going to do this manually. Automatically, it's more complicated than than this. Simulation is one thing. Doing in the practical thing, it's completely different. I mean, yeah, but yeah. It's everywhere this way in engineering. In engineering, especially in electrical engineering, I don't know the other ones, but everything that you simulate, you have to expect many things to debug when the in the real project, in the real life. It's no matter if you are working with electronics, programming, or whatsoever. You have to always debug. You can simulate, of course. You simulate just to organize yourself, just to keep you organized. But yeah, it's never going to work as 100% as you simulated. So let's. Okay, we are the microcontrollers, and we are going to set the output on. That means the input of the PLC is going to be set on. We're going to give the PLC orders to be ready to send us the bits by pulse, right? So, okay, so we have here the loop to send the bytes set. Let's give the first impulse. You know, everything is ready to be set and only to rotate and also to be sending to output. So let's be the microcontroller said, okay, I'm going to send you the first input. I'm going to send you the first signal on, and the value here is 0. So this value is 0. The output is not going to be set because the value is 0. Yeah, value is 0. Output is not going to be set because the value hexadecimal into the 120 volt is AAA. It means 0 1 0 1 0 1. So it starts by 0. So 0 1 0 1 0 1 is going after the second on. It's going to be rotating. So let's do this. Let's do this 16 times. So force off. There we go. So now by off is rotated. So now is the bit rotated and it's on because here is the bit is on. So the output will be on as soon as we, as microcontrollers, will set to on. Check. No, there we go. So this gives the information to the microcontroller that the second bit is 1. The first bit was 0. The second bit is 1. So now we're going to make this 15 times happening. Let's go. So on, and you're going to be seeing the changes, the rotating bits. Now on, and now off, on, off, force on. There we go. 1, force off. Off is rotating. Force on. 0, force off. Force on is 1. Force off. Oh, it's boring. Force on. It's 0. Force off. Rotates. Force on. It's 1. Force off. Rotating. Force on. It's 0. Force off. Rotate. So let's go. No, yeah. So on and 2 more times. It's going to be boring. In real time, this is really quick. So, but simulation. So the last bit was 1. Anyway, this counter is not used either way. It's just for debugging, just for me to debug. So, but this is how I did it. I mean, you can do in very different ways. Yeah? You can rotate the word right. You can rotate the word left. You can even use pointers. Uh, you can even point in one bit at the word and then make the word rotate. I mean, you can do this from different ways. I mean, yeah, you can even also program in a different language. But yeah. Anyway, this is how this works, and I'm going to put this together with a microcontroller. After this we're going to see the microcontroller code. It's a bit complex, yeah, but I mean we shouldn't expect simple things. Uh, so let's look at the microcontroller code.